Go beyond f prime, we can talk about f prime prime, which we also call double prime. Every time I go down a level, we're talking about taking another derivative. And if all goes well, I'm even going to go one step further in this link of derivatives, and we're going to talk about
F prime prime prime.
Good, thank you for being there for me. Absolutely not. We are not going to go down and talk about f triple prime. We're going to go up and talk about the antiderivative. That's where we're going big picture. Right now, we're just focusing here on the FF prime relationships. That's all that we're doing. And my goal is to get you guys really, really good at this. So, here we go. Excellent. She's back. We can get started. Yesterday, you guys remember we had a graph. I gave you the graph of f. We played around with f prime. We're like, ooh, look at what f prime's doing. That's so cool. I'm going to give you 5 minutes. I am not giving you any graphs. In the next 5 minutes, working at your tables, the person who is the youngest, the baby in your group, gets control of the cups. Miguel, why don't you join a group? Let's pretend you have some friends here. Okay. So on the handout, you have 5 minutes. Here's what you're doing. Okay, hold on. I know everyone's trying to figure out who's the baby. You have 5 minutes. For all of these statements, I'm telling you something about f, you're telling me something about f prime. So let's do one together. If f has a cusp point, can you guys show me a cusp point? A cusp point, so I'm over here. F has a cusp point. Now, all cusp points don't look like that. A cusp point could look like that, right? What I know is that it is sharp. So you have a cusp point at x equals c. If f has a cusp point, then what do we know about f prime at that point? I want to get some hands on that. If f has a cusp point, or this thing, I see 1, I see 2, I see 3, I see 4, I see 5. Salma, what do you know about f prime?
It's not differential.
I'm sorry, what?
The F1 is not differential. The function is not differential.
You're right. If you have a cusp point, the function is not differentiable, and we don't use the word it. Ever. Ever, ever, ever. I want to know about f prime. What do you know? I agree cusp point means not differentiable, but what do we know about f prime? There's something that you know. Oh, so sad. If a function is differentiable, what does that mean?
It's continuous.
If a function is differentiable, it means the derivative exists. If differentiable, then the derivative exists. So if you have a cusp point, then you're going to say f prime does not exist. F prime does not exist, but now don't be too strong on me. F prime does not exist means doesn't exist anywhere. Too strong. F prime doesn't exist at x equals c. 5 minutes. Finish these off. This last one I want you to add on says if f has a horizontal tangent line at x equals c. Tell me about f prime. 5 minutes. Fill them out. If you don't know, use the cups. So f is increasing and prime is positive. Feel comfortable with that? Decreasing, negative, good. Cusp point does not exist. Vertical tangent line, true. F prime does not exist. But vertical asymptote. Take a graph of the vertical asymptote. Just sketch one on paper. So graph of the vertical asymptote. So many choices. So many choices. Tell me about the derivative. happens with the derivative if you have a vertical asymptote? True, it doesn't exist, but something special happens with the derivative. Something happens.
Oh, doesn't it go the way up?
Right? If you're like, here's my vertical asymptote, right?